Welcome to the Blue Collar Tutor Test Preparation Series for the New York City Fire Department S-12 Certificate of Fitness for Citywide Sprinkler Systems. This series will provide you with a convenient review of the material for the written exam. This preparation course includes information taken from the 2008 New York City Fire Code, Chapter 9, Fire Department Rules, Chapter 9, and the National Fire Protection Agency, Standard 25, 2002 edition, for inspection, testing, and maintenance of water-based fire protection systems. It is critical that you understand this material to help increase your chances of passing the exam. A transcript of this material is provided for free by the New York City Fire Department. See the link in the description below to upload the transcript and additional reference guides that you'll need to familiarize yourself with for the exam. Instructions on the application process to register for the exam are also provided via the link below. If you haven't already, it is recommended to watch the brief overview video in this series at least once before moving on to the subsequent volumes. After an initial run-through of the entire series, refer back to these volumes as often as you need until you feel confident with the material. Once you've familiarized yourself with all of the material in this course, continue on to the practice test sections at the end of the series. There you will find over 200 questions to test your knowledge of the material. 10. System components. Sprinkler heads. Sprinkler heads are made of metal. They are screwed into the piping at standard intervals. The water is prevented from leaving the sprinkler head by an arrangement of levers and links. The levers and links are soldered together on the sprinkler head. The solder is a metal alloy with a fixed melting point. Other types of sprinkler heads use a glass bulb which expands and breaks under heat. The sprinkler head is factory tested to withstand at least 400 psi without injury or leakage. If properly installed, there is little danger of the sprinkler operating unless it is damaged. There are over 50,000 different variations of sprinkler heads. Sprinklers manufactured after January 1, 2000 are required to have an SIN or Sprinkler Identification Number. Sprinkler heads manufactured prior shall be replaced as required with sprinkler heads of similar characteristics such as orifice size, temperature rating, and deflector orientation. Recalled sprinkler heads. A sprinkler head that has been recalled is called the cycling sprinkler. This sprinkler cycles water on and off depending on the temperature. When the disc reaches a temperature of 165 degrees Fahrenheit, the valve opens, permitting water to flow. When the disc temperature cools, the valve closes to shut off the water. These sprinklers and all other sprinklers listed for recall at www.cpsc.gov are subject to replacement. Some sprinkler heads are designed to be used in special situations. Sprinkler heads exposed to corrosive conditions are often covered with a protective coat of wax or lead. Corrosive vapors are likely to make automatic sprinklers inoperative or slow down the speed of operation. They can also seriously block the spray nozzles in the sprinkler heads. They can damage, weaken, or destroy the delicate parts of the sprinkler heads. In most cases, such corrosive action takes place over a long time. For this reason, the sprinkler heads must be carefully watched for signs of corrosion. Care should be taken to make sure that the protective coating is not damaged when handling or replacing the heads. Spray pattern of sprinkler heads. The best way to put out a fire is to spray the water from the sprinkler head downward and horizontally. The spray pattern will also prevent the spread of the fire. The force of the water against the deflector creates a heavy spray which is directed outward and downward. The shape of the deflector determines the spray pattern of the water discharged from the sprinkler head. Usually, this is an umbrella-shaped spray pattern. At a distance of 4 feet below the deflector, the spray covers a circular area having a diameter of approximately 16 feet when the sprinkler is discharging 15 gallons per minute. Sprinkler spray patterns must not be obstructed by building components or storage. Systems using large drop sprinkler heads. Large drop sprinkler heads are special sprinklers designed to discharge large drops of water from the head. These sprinkler heads are used to break through the strong updrafts of high-challenge fires. In places where the temperature is normally high, such as boilers, ovens, and drying rooms, a sprinkler head with a higher temperature rating must be used. This is to make sure that the sprinkler head does not discharge water at the wrong time. If heads with a high temperature rating are used in an ordinary room, like an office, an apartment, and store, the value of the sprinkler protection is greatly reduced. This is because the temperature will have to increase much higher for the sprinkler heads to open. Sprinkler systems are excellent for controlling fires. However, they can cause water damage if they are not shut down soon after the fire has been extinguished. No control valve on the system should be closed except on the order of the fire officer in charge. If the fire has been completely extinguished, the building owner or their representative may close the control valve. Sometimes the fire department has a difficult time finding the control valve to shut down the system. This problem can be prevented by keeping a small sketch of the sprinkler system and the position of the control valves. This sketch should always be readily available. This sketch is very helpful to the firefighters when they have to work with the sprinkler system. Buildup of foreign material on sprinklers. Sometimes conditions exist which cause a buildup of foreign material on sprinkler heads. This may prevent the sprinkler head from working properly. This buildup is commonly called loading. The buildup of foreign material insulates the sprinkler head. This buildup prevents the sprinkler from opening at the desired temperature. If the buildup is hard, it may prevent the sprinkler from opening. Replace loaded sprinkler heads with new sprinkler heads rather than attempting to clean them. If the deposits are hard, attempts to clean the heads are likely to damage them. This damage may prevent the sprinkler heads from working properly. The damage may also cause the sprinkler head to leak. Deposits of light dust are less serious than hard deposits. Dust buildup may delay the operation of sprinkler heads. However, it will not prevent the eventual discharge of water. Dust deposits can be blown or brushed off. If a brush is used, it should be soft to avoid possible injury to sprinkler parts. Scouring or acidic liquids are likely to damage the sprinkler heads and should not be used for cleaning. Hot solutions of any kind should never be used to clean the sprinkler heads. Removal of protective caps and straps on glass bulb sprinklers shall be performed at the time of installation. Spare sprinkler heads. Sprinklers required for emergency replacement must be representative of the type of sprinklers installed along with the proper wrenches. These wrenches shall be provided in the spare head cabinet. It is critical sprinklers be replaced with devices that will perform similarly to the original system sprinklers. Sprinklers that are replaced during an emergency by unlicensed individuals require that the devices used have been verified appropriate for the protected area by a master fire suppression piping contractor. After activation by fire, sprinklers in close proximity to the affected heads are recommended to be replaced. A stock of spare sprinklers, not less than 6, shall be kept on the premise where the temperature does not exceed 100 degrees Fahrenheit, and shall include all types and ratings installed in the protected facility and provided as follows. Under 300 sprinklers, 6 spares are required. For 301 to 1,000 sprinklers, 12 spares are required. If there are over 1,000 sprinklers, 24 spares are required. Pressure tanks. Pressure tanks are enclosed water tanks of limited size. Air pressure in the tank permits forceful discharge of water in the tank into the sprinkler system. A pressure tank may be used as a primary or secondary water supply for a sprinkler system. A pressure tank is usually housed in an enclosed structure. The temperature in the enclosure is kept at 40 degrees Fahrenheit or above. The heated structure may be located anywhere in the side or even outside of the building. Pressure tanks are to be maintained at approximately 2/3 full of water and 1/3 full of pressurized air. The minimum acceptable air pressure inside the tank is 75 psi. The air pressure in the tank is automatically maintained by an air compressor. The maximum gross capacity of pressure tanks is 9,000 gallons. Some sprinkler systems require more than 6,000 gallons of water. When this occurs, several pressure tanks are used in combination to supply the system. Standard pressure tank. Pressure tank alarms. All pressure tanks used to provide the required primary water supply for a sprinkler system shall be equipped with 2 high and low alarm systems. One system monitors the high and low air pressure. The other system monitors the high and low water levels. The alarm system automatically monitors the air-to-water volume ratio, which should always be 1 air to 2 water. An alarm signals the certificate of fitness holder or central station operator when the water level or the air pressure falls too high or too low. When this occurs, the pressure tanks should be adjusted or repaired immediately. Supervision of the pressure tank. The pressure tank may also be supervised by an approved central station company which monitors the entire sprinkler system. Supervisory devices are installed in the pressure tank. These devices alert the central station company when there is a problem with the tank's water level, air pressure, and water temperature. The devices also alert the central station company when water has been discharged from the tank. When sprinkler heads have fused and water has been discharged from the tank, the local firehouse is notified. The central station company notifies the certificate of fitness holder when a problem is caused by equipment failure. Repairs and adjustments shall be made quickly to return the pressure tank to good working order. Gravity tanks. Gravity tanks are used for water storage. They are made of wood, steel, or concrete. Gravity tanks are used as a primary or secondary water supply source for sprinkler systems. A gravity tank system delivers water from the tank through the sprinkler system without the use of pumping equipment. A gravity tank should be at least 25 feet above the highest line of sprinkler heads that it supplies. Tanks may be located on the tops of buildings or raised on tall supporting towers. The water pressure in a gravity tank system depends on the elevation of the tank. This is the main advantage over other kinds of systems. For every 1 foot the tank is above the discharge outlet, 0.433 pounds per square inch of water pressure is generated. In other words, the higher the tank elevation, the greater the water pressure. The gravity tank is extremely reliable. It does not depend on the operation of mechanical equipment to supply the sprinkler system. Automatic fill pumps supply the water to most gravity tanks. The pumps fill the tank at a rate of 65 gallons per minute or more. The floats turn on the fill pump when the water in the tank is too low. The floats shut off the pump when the desired water level is reached. The floats make sure the gravity tank always has the right amount of water to supply the sprinkler system. All gravity tanks have an overflow pipe that drains off excess water in the tank. This happens if the floats do not turn off the fill pump. A fill pump is not necessary if the water pressure in the city water main is able to keep the tank filled with the correct amount of water. Gravity tanks are exposed to very low temperatures. All parts of the gravity tank must be insulated or heated to keep the water from freezing. Several methods are used to heat the tank and the pipe that supplies the water. 1. Hot water is circulated by gravity. 2. Steam is discharged directly into the tank. 3. Steam coils are placed inside the tanks. 4. Heat from the sun is used. The certificate of fitness holder can find out the temperature of the water by using a thermometer. The thermometer is located near the heating device. Severe damage can occur to the piping and the tank if the water inside the tank freezes. During freezing weather, the temperature of the water inside the tank and the riser must be checked daily. The temperature of the water shall always be at least 40 degrees Fahrenheit. Ice should not be allowed to build up on the gravity tank. The extra weight of the ice might weaken the supports of the tank and cause the tank to collapse. Falling icicles may also cause damage or injury. It is essential to be sure that the tank is properly heated, insulated, and carefully maintained. The gravity tank must always have a full supply of water. A full tank of water is needed to ensure the sprinkler system works properly during a fire. Keeping the tank full of water also prevents wooden tanks from shrinking. A full tank of water helps keep steel tanks from rusting. Gravity tank supervision. The gravity tank shall be constantly monitored to ensure that the tank and its parts are working. Electrical supervision devices monitor the water temperature and the water level in the gravity tank. These devices send signals to an approved central station company about the water level and water temperature. The central station company notifies the certificate of fitness holder when a problem with the gravity tank is detected. The certificate of fitness holder shall correct the problem as soon as possible. The supervisory devices are sometimes called high and low alarms, since they also send audible signals to alert the certificate of fitness holder or central station when there is a problem. The main reason a sprinkler system supplied by a gravity tank fails during a fire is not enough water in the tank. The sprinkler system cannot be supplied if there is not enough water in the tank. A proper water level shall be maintained. The centrifugal pump. The centrifugal fire pump is the standard pump currently used in fire protection systems. This is the preferred pump because it is reliable, compact, requires low maintenance, and it can be powered by a variety of drivers including electric motors, internal combustion engines, and steam turbines. Principle of operation. The water available to the centrifugal pump must always be under pressure because the pump cannot lift water for the supply source. A water tank can be used if the tank supplies the pump due to gravity. In other words, the weight of the water forces the water to flow into the pump. This type of water tank is called a suction tank. The water flows from the tank through the supply inlet into the pump. As the water passes to the center of the pump, it reaches a rotating impeller. This impeller is designed to grab the water on the inlet side of the pump and then discharge the water under increased pressure into the fire protection system. Depending on the model, centrifugal pumps are capable of discharging water from 25 gallons per minute up to 5,000 gallons per minute. Most centrifugal pumps have a single impeller and are therefore commonly called single-stage fire pumps. The vertical turbine pump. A vertical turbine pump is really a modified centrifugal pump that has the capability to draw water from streams, ponds, and wells. Unlike the standard centrifugal pump, the vertical turbine pump does not need the suction supply to be under pressure for it to operate. Instead, it draws the water into the pump by suction. When it reaches the rotating impellers, the water pressure is increased and then forcefully discharged into the fire protection system. Although the vertical turbine pump is capable of drawing water from wells, it is generally not recommended to use a well as the main water supply source because it may dry up without warning. Should the well dry up, it would make the turbine pump useless. It is better to draw water from the well and to fill a water storage tank. A fire pump should then be attached to a more reliable supply source, such as a storage or a suction tank. When using a pump to draw water from a suction supply source, it is important to ensure the water intake hose, foot valve, and screens are inspected regularly. Mud, gravel, and leaves may cause damage to the pump or obstruct the sprinkler system piping. Pump activation. A fire pump can be started automatically or manually. The pump can be started automatically by an electric controller or an engine controller. These controllers activate the pump when there is a drop of water pressure or water flow in the fire protection system. The controllers are adjusted so that a minor drop in water pressure or minor increase in water flow due to a small leak will not activate the pumps. The controllers for the fire pumps are expensive, require extensive maintenance and periodic testing. Where an electric motor drive is used, a standby power generator is sometimes required. If an engine controller is used, the appropriate fuel storage tanks should be filled and checked regularly. When manually activated pumps are installed, they are usually used in combination with a gravity tank or a pressure tank. These tanks are designed to operate when there is a pressure drop in the fire protection system. The operation of the pressure tank and the triggering of its supervisory devices, or alarms, alert the certificate of fitness holder that the fire pump must be activated. The certificate of fitness holder, or another responsible individual, should then manually activate the fire pump according to the manufacturer instructions. Manually operated fire pumps are often found in industrial and manufacturing occupancies having personnel on the premises at all times. The certificate of fitness holder may only activate a manually operated vertical fire pump arranged as described above. Sometimes remote push buttons are used to activate the pump. These remote push buttons are designed to start the pump but not to stop the fire pump. Pressure maintenance pumps or jockey pumps. Pressure maintenance pumps, sometimes referred to as jockey or makeup pumps, are often found on sprinkler systems. These pumps are designed to automatically operate when there is a slight drop in pressure due to the leakage in the system or a pressure surge. The jockey pump restores the pressure in the fire protection system to the desired level. When the drop of pressure in the system is greater than the capacity of the jockey pump, the fire pump is activated. Booster pumps/special service pumps. Booster pumps are sometimes used in sprinkler systems. These small pumps with limited power are usually located in the basement or taking suction from gravity tanks. The booster pump is used when the water pressure available at the highest sprinkler head does not quite meet the needs of the sprinkler system. This small pump increases the water pressure in the sprinkler system until it reaches acceptable levels. The booster pump should not be confused with the fire pump or the jockey pump. Operation and supervision. When fire pumps are activated by electric automatic controllers, it is essential that they are constantly monitored to ensure the availability of the electrical power supply in case of an emergency. For this reason, supervisory devices are installed on the pumps to alert the certificate of fitness holder and/or a central monitoring station when there is an electrical power failure. In cases where steam turbines or internal combustion engines are used, similar supervisory devices are installed to signal when there is a problem with the controlling equipment. Fire pump location. The fire pump should be housed in a room that is fire-resistant or constructed of non-combustible material. The pump room should be located as close as possible to the fire protection system. The pump room should be kept clean and accessible at all times. The fire pump, driver, and controller should be protected against possible interruption of service. The temperature inside the pump room should be maintained above 40 degrees Fahrenheit at all times to prevent freezing of the water. The pump room should only be used for fire protection functions and not for general plant operations. No storage is permitted in this room. This concludes Volume 6. Repeat each chapter as often as you need until you feel confident with the material. Post any follow-up questions in the comment section below. Subscribe to stay current on updates to existing exams and to be notified of new test preparation content. If you found this video helpful, please be sure to leave a like. Thank you for watching.